Once again, welcome to the LJ Institute of Engineering and Technology. Let's start with the today's that means our syllabus mathematics 2 and chapter we know that first order ordinary differential equations, and today's topic is solution of differential equation of first order and first degree. This is the our main topic of this syllabus. That means first order and first degree. We will learn the solution of ODE of the type first order and first degree. Here the chapter name is first order ODE. So here first order, and we will first learn about first degree. Then we will see the higher degree. Okay. So let's start with the chapter topic. Solution of differential equation of first order and first degree. The ODE of first order and first degree is of the form this or this or this. Okay, these are the different form of first order first degree. That means in this each and every form you can see that we have only first order, and the power of this order is 1, so we have first degree. Okay, in this form you can find this concept. Now this is another form of first order first degree differential equation. Now the general solution of such equation will contain only one arbitrary constant, because as I told, if the differential equation is of order 1, then we have only one arbitrary constant in the general solution. Okay, in order to solve this above equation we need to check two conditions. Which two conditions? That existence and uniqueness of the solution, and second, actual procedure to find the solution. So we have this different type or different methods to solve the differential equation. Okay, we cannot solve each and every first order first degree differential equation, but if we have the ODE of the form first order first degree in the particular given type, then we can solve. Okay, and these are the different method. First is variable separable method. Second is reduced to variable separable method. To understand this method, you all have to first understand this method, and we will use this method to solve this reducible to variable separable. Similarly, we have homogeneous differential equation. In this also we will use variable separable and reduced to variable separable. We have third is non-homogeneous differential equation. Fourth is exact differential equation. Fifth is a non-exact differential equation. That means we will find the integrating factors, that we can say that IF. You already studied this some of this method in your school level 12th standard. Okay. We have another is linear differential equation, or we can say that Leibniz differential equation, and 8 is Bernoulli differential equation, or we can say that reducible to linear differential equation. Out of this we have only 4 methods. Actually we have 4. This is the entire one method, that variable separable by using this, reduced to variable separable, homogeneous by using this, non-homogeneous, exact and non-exact both are similar. Like you have to just reduce a non-exact into exact, then you have to use the method of exact. Similar way linear and Bernoulli. Okay, so these are the 8 different methods, and which are the most important. So these 3, and these are the most important. Non-homogeneous differential equation example based on this method is many times not asking, so you have to just focus on these remaining 7. Okay, so first we'll start with the first method, variable separable. Okay, so what is variable separable and how we can solve this type of differential equation? So if differential equation of the type dy by dx is equal to f of xy can be converted into this form, that means if we can separate the variable x, function of x and function of y, if we can separate, then we have to take the function of x with dx and function of y with dy. This type of differential equation or this type of method is known as variable separable method. Okay, and the general solution of variable separable is given by like this. Just by separating this variable, you have to just integrate both the side. So integration of this on the left hand side, integration of this on the right hand side, and plus c. This is our integral constant, common integral constant of these two. Okay, and by integrating these two, we have the final answer. And c is our arbitrary constant. Now you can replace this c by this different log c or tan inverse c or e raised to c or sec c or any trigonometric tan c or any trigonometric function. Okay, or you can replace c square, c dash, c1, anything which is for which is convenient for your example. Okay, so how this happened and how this work, let's have look on the example so we'll understand better. So we have this first example, so easy. Solve y into y dash plus 25x is equal to 0. So we have this example that y as it is, y dash, that means dy by dx. Now just observe, okay, because there is no mentioned any method. Okay, there is no mention any method's name in given example. Just examples question is solved, same as higher order. Okay, in higher order chapter you already solve this kind of example, but there you have higher order, that means y double dash, y triple dash. Okay, but here we have only one derivative dy by dx, that means y dash, and only 1 degree. Okay, so just observe if we can separate the variable, yes or no. If you get answer yes, then you have to separate. If you get answer no, then you have to think about the different another methods, because we have total 8 methods. Okay, so if we take 25x on the right hand side and if we take dx on the right hand side, so we have this variable separable. So we can here we can separate this variable, so we will use this method. Okay, so after separating these two, just we have to integrate both the side. So integration of left hand side, integration of right hand side. So by after getting integration, we will put c. Okay, so integration of y is y square by 2 minus 25 as it is, integration of x is x square by 2, and plus c is the constant, arbitrary constant of this and this total. Okay, so this is our final answer, or you can simplify further by taking LCM and all. So by taking LCM, you can also find the simple, if you simple taking LCM, so 2 is the LCM, so 2 goes with this c, so we have this x y square plus 25x square is equal to c. You can left with this answer also, but if you want to take this 2c as a c dash, so you can put 2c is equal to c dash, and you have to mention here, which is our final general solution. Okay, why we are using c dash? Because already c is used, that c dash, that is not derivative. Okay, you can use c1 also instead of this c dash, so you have to write here c1. So c1, c dash, any constant you can use. Okay, so simple method. If you can separate the variables, you have to use this method. Second example will give you better idea. So we have this example, and here in this example we have some condition. If y is equal to 2, when x is equal to 1, that means this kind of example is known as initial value problem. In this kind of example, we have this initial value is given, which we will use after getting general solution, and by using this we will find the particular value of that constant, arbitrary constant, and we will get the particular solution. Okay, but example mention only solve. Either instead of this solve, it is given also that find or solve IVP, initial value problem. Okay, so there is no difference between this solve or solve initial value problem. So first we will start with this differential equation only, and we'll take x square y dx on the right hand side. Now dy and dx cannot go on the denominator. Okay, that is the first concept of this. So you have to put dy and dx in this multiplication form. So we will take this 1 plus x cube on the right hand side with dx, and this y will take on the left hand side with dy. So if we take y on the left hand side, so y become 1 by y, and this x square and 1 plus x cube on the denominator. Now we have this 2 different function with different variable y and x. Now we have to think first it is integrable. So integration of 1 by y is, we know that, log y. And what is the integration of this? Directly we don't have a formula, but here we can use one formula, that integration of function and its derivative in the numerator, we have the formula log of f of x plus c. Okay, so we have this denominator is a function 1 plus x cube, and derivative of 1 plus x cube is differentiation of 1 is 0. The derivative of this x cube is 3x square. So x square is there, we just need 3. So we will multiply with 3 and divide by 3, or we can multiply on the both side 3. Okay, now we can integrate both the side. So we will start with the integration. So 3 constant, integration of 1 by y is log y, and this differentiation of this term is this entire, so log of this denominator. And here we will not just taking only c, we will take log c. Okay, now we have concept of log. 3 goes with this power, and we know that log a plus log b, that means log a into b. So we will use that concept only. Okay, and by taking anti-log on both side, so log will be cancelled out by taking anti-log. Okay, so y cube is equal to this, and this is our final general solution, which is our general solution. Now we have initial value is given, and initial value is when x is equal to 1, we have y is equal to 2. So we will put this value in this general solution. So we have 2 cube is 8, and 1 plus 1 cube is 1. So 1 plus 1 2, and we have value of c is 4. Now put this value in this equation number 1, and we will get the particular solution. So whenever initial value is given, we will find the particular solution. Okay. And same as based on this, we have, these are the examples. Okay, these are the example that you have to solve by this method only, variable separable. Okay, so you have to just think, is the given that differential equation is separable variable, that means you can separate the variable, then you have to solve by this method. So these are the simple examples, just try to solve yourself. If you find any queries, then you can contact me. These are the 6 simple example, and these 2 example as previous example, like initial value problem. After getting general solution, you have to use this initial value and find the arbitrary constant, you will get particular solution. In here, how you find, how you decide what is the value of which variable. So whenever we have this form is given, you have to consider this y of x is equal to y, that means y of x0 is equal to y0. This is the value of x, and this is the value of y. So here we will write that when x is 1, y is root 3. Okay, and in last example we have two variable r and t. So r of this, so this is our t. So when t is equal to 0, r is equal to 2.5. We will use this value after getting general solution. Okay, so we have the simple 8 example that you have to just try. Otherwise, if you have any query, you can contact me, or I will give some idea, or I will solve your doubt in Zoom lecture. Okay, so thank you for today's lecture, and keep trying, keep practicing, and you know that practice make you more perfect for the examination. So thank you for today's lecture.